Welcome to qnawire.
Okay, so the first thing we do for this problem is to draw a vector diagram. So for the problem, it says we have an airplane pilot that wishes to fly due west. Okay, so that means that we want the velocity of the plane relative to the Earth to be in the westward direction, so the negative x direction here. So it's going to be this vector right here. And then we also know that the wind is blowing toward the south, and it gives the velocity of the wind to be 80.0 kilometers per hour. Okay, so velocity of the wind here is pointing in the southward direction. Okay, it's going to be 80.0 kilometers per hour. Okay. Okay, so then for part A, it's saying if the airspeed of the plane is 320.0 kilometers per hour, in which direction should the pilot head? Okay, so it's going to be so velocity of the plane is going to be the VP here. Okay, so this velocity is going to equal 320. Actually, let's do it over here. So we're given that VP is equal to 320 kilometers per hour. Okay. So we know that the velocity of the plane is going to have to be in this direction here because we want the plane to fly to the west. And if we have the wind blowing south, that means we have to start the plane above the westward direction like this, okay? Because if it's above here and the wind's going south, it's going to make the plane go in the westward direction then, if it's at a certain angle here. Okay, so our goal is to find this angle theta, which is the direction. Okay, and then after you find the angle, for part B, it's asking what is the speed of the plane over the ground. Okay, so it's going to be the velocity of the plane relative to the Earth. We want to find that then too once we find the angle. Okay. So now what we can do is we can use the relative velocity equation. So let's look at the velocity of the plane relative to the Earth. Let's look in the x direction first. Okay, so the velocity of the plane relative to the Earth is going to be equal to velocity of the plane in the x direction plus the velocity of the wind in the x direction. Okay. So now let's break this in components then. So first let's look at the velocity of the plane relative to the Earth here. Well, we know this is in the westward direction, so it's going to be a negative value. Okay, so we're going to have, so the velocity of the plane relative to the Earth in the x direction is just going to be a negative value. So we can just write negative velocity of the plane relative to the Earth. Okay. Now what about the velocity of the plane in the x direction? So for that, we can use, actually, let's read it like this. Okay, so let's look at these individually here. So the velocity of the plane in the x direction is going to be a negative value because the velocity of the plane is pointing in the negative x direction here, because the vector is in the negative x direction and the positive y direction here. Okay. So since we're looking at the x direction, looking at velocity of the plane for the x component of the velocity of the plane here, so the vp comma x. So we're going to have a negative 320. And I'll just take out the units now, just so it's less writing. So I have negative 320 times cosine of theta. And we're doing cosine of theta because it's in the x direction. We have the x component here. Again, it's negative because it's in the negative x direction. Okay. Now what about the velocity of the wind? What about the x component of that now? So the velocity of the wind is only going in the negative y direction here. It's going south. So it's not going to have an x component. So we just have a plus 0 here. Okay. So we have that for the x direction now. So we actually cancel out the minus signs here. So let's just cancel these minus signs. So the velocity of the plane relative to the Earth is equal to 320 times cosine of theta. Oh, and this, yeah, so this shouldn't have a vector here actually. So yeah, let's get rid of the vector here. Because we already give it a sign here, so it's not going to have a vector anymore. Okay, so now we have 320 times cosine theta. So that's, let's call this equation 1. Okay. Now we can use another equation if we look at the y component. So look at the y component of the velocity of the plane relative to the Earth. So it's going to be the same formula, but we have y components now. Okay, so now let's look at the y component of velocity of the plane. Well, looking at the y component, it's going to be a positive 320 times sine of theta. Because if you look at the vector for the velocity of the plane, it's going to be pointing in the upward, so it's going to be pointing in the positive y direction. So we have positive 320, and it's times sine of theta because it's in the y direction. Okay, so it gives us the velocity of the plane in the y direction. Now let's look at the velocity of the plane, or let's look at the velocity of the wind in the y direction. So again, the wind is going south here. So that means that it's going to be in the negative y direction. So we're going to have a minus 80 here. Okay. So now we have that. So now we have, so now what about the vector of the velocity of the plane relative to the Earth in the y direction? Okay. Well, we know that the velocity of the plane relative to the Earth is going to be pointing just in the west direction. So that means it's in the negative x direction. So there's no y component then. So the y component of the plane relative to the Earth is going to be 0. Okay. It gives us our second equation now. So what we can do is we can use this equation here and then solve for theta. So I can rearrange the equation and solve for theta. So I'm going to get theta is equal to inverse sine of 80 divided by 320. Okay, so if I compute this, I'm going to have an angle theta. Let's just continue the problem up here. So I'm running out of room. So theta is going to be 14.5 degrees. And this is going to be relative to the west direction here. Okay, so we could say it's 14.5 degrees north of west. Okay, because it's that far away in the northward direction from the west direction. So we could say north of west. Okay. And now we can find the velocity of the plane relative to the Earth by using the first equation here. So using the first equation, we could just plug in the value for theta that we just calculated here. So we have 320 times cosine of the angle theta. So that's going to give us a value of 310 kilometers per hour. Okay, and again, that's going to be pointing in the westward direction. So say 310 kilometers per hour west.